Hello, my name is Danny Tran, and this is the video explainer for the final assignment. So in this assignment, we are going to train a perceptron with a quadratic loss function using gradient descent, and we're going to visualize the evolution of the weights during training. So that's our goals, and we're given that the activity rule is the sigmoid function, pretty standard. We're using a fixed bias of b equals -1, and we're also given the gradient of the log likelihood function, the derivative, and the gradient descent learning rule is all this, and this is what we want. So this differs slightly from the perceptron notebook that we are following. This is my updated notebook, and so here we are initializing our modules, generating our patterns. So following the assignment, we wanted n equals 2, p1 equals 100, p2 equals 100, labels z equals 0, z equals 1 respectively, and the spread is 0.5. So if we go down here, we follow everything. Pretty simple stuff. And so from the past Jupyter Notebook, we are using the same activity with a different log likelihood function. I kept it just to note the difference. And then in class we used b equals to the negative weight, initial weight. But here we're using b equals -1. And so we change that here, b equals -1. Sigmoid function is the same, log likelihood is the same. Yes. Yes, perfect. And then, so for alpha equals 0 is what we want. So the first one is we're using 10,000 training steps, 0.001 learning rate, and alpha equals 0 for the first perceptron. And this is what we did here. We just followed everything. And we see that the weights, they keep going up and up and up and up. And when we actually plot the weights, we see here that the weights, they don't converge to a single value. So they keep increasing. And I would assume, based on this graph, that as our learning epochs increase, our weights are going to infinitely increase. And this makes sense because our alpha is equal to 0, and so there's no weight decay. And then we're asked to increase alpha level to 0.5, which is quite high. And so we basically just copy pasted all this stuff into a new perceptron with alpha equals 0.5 is the only difference. And so here we see that the weights, they start converging at about the 2001 step mark. So 1.84, 1.86, yeah. So they start converging, and once we plot them, you'll actually see that, yes, they do start to converge into a straight horizontal line. And I would assume, based on this graph, that as the learning epochs increase, then they would stay at this value. Right, and so that's the difference, the main difference between alpha level 0 and alpha level 0.5. In one case, we don't have a weight decay, and so the weights would infinitely increase, as we learned about in class. And when we do have a weight decay term, alpha equals 0.5. And so because of that, we see that the weights, they converge, and our function, or our perceptron, works better than before. All right, that is all. Thank you for the class.